Okay, this is going to be lecture problem number 4 for statics, chapter 3. All right. So, the triangular plate ABC is supported by ball and socket joints at B and D and is held in the positions shown by cables AE and CF. If the force exerted by cable CF at C is 33 newtons, determine the moment of that force about the line joining points D and B. Interesting. So let's start out by listing the points. We're going to list B, C, D, and F. Point B is going to be 1.2, 0.35, and 0. Point C is going to be 0, 0.9, and negative 0.4. Point D is going to be 0, 0.7, and 0. And then point F, 0.6, 0, negative 0.6. All right. From here, we're going to note that the formula or equation we're going to use is m equals lambda r cross f. Now note that our axis of rotation is here, this line here. We're going to have this as an R point, but we also have this as an R point. The reason being is this is the this axis, this is the force vector. Pretty sure. So noting that, am I on eraser somehow? What happened here? Give me back on the brush. Give me back on the brush. Am I in invisible ink now? Which one's the... Well, that's right, but the size is way wrong. It's just, oh, not quite right. Is it? Yeah, let's call that right. That's size 10. Wait. I keep mine a size 2. Ooh. Where were we exactly? Was I at a size? Let's just call it close enough. Come on. Let's do a brush at a size 10. Size 6. Call it an even 5. No. Brush tool. Won't go up in size now. Get off the eraser part. Perfect. Why not? Let's leave it. Where were we? Force vector. Perfect. All right. So cable CF. So let's just find what vector CF is, and then we're gonna need to find R. Now we could say that R is DC. I'm gonna say, or DB. We're gonna need to find DB. DB is axis of rotation. But CF, yes, that is. That's our R right there, isn't it? So let's why not do BF instead? Yeah. R BF. We don't really need to call it. We can call it RBF. And the vector is going to equal negative 0.6, negative 0.38, 35, and negative 0.6 again. Okay, and now we're going to also want to note what CF is. Since no, not CF. DB. Give me negative 1.2. It's going to be negative 0.35, and it's going to be 0. And we're given the force exerted at cable CF. So the force at CF equals FCF lambda CF. With that being said, I think we do need to find CF, don't we? That's how we're going to get our force. Okay. Well, shoot, if we were going to take CF anyway, we could have made CF our point. Whatever. We'll just keep going this way. This seems fun. Doesn't this just seem fun? Yeah. So, CF is 0.6, negative 0.9, negative 0.2, and lambda CF is 0.6 over 11. I have minus 0.9 over 1.1. It's 1.1, not 11. J hat minus, or no, yeah, minus 0.2, 1.1. K hat. And then we can also just do lambda dB and then lambda for BF. So lambda BF is going to be negative 0.65 I hat R is just 6 minus 0.38 J hat minus 0.65 K hat. Okay. And then lambda dB is 1.2 over 1.25 I hat minus 0.35 over 1.25 J hat plus 0 K hat. Okay. So now here we have, this gives us our force. We can find force with this. We've got our R value, and then we've got our axis of rotation. Now what we need to do is do R cross F, which is going to look, well, first we need to find F, which is why we have this here. So CF, FCF, this is going to be 33 times 0.6 over 1.1 minus 0.9 over 1.1 minus 0.2 over 1.1, which gives us a force of 18 I hat minus 27 J hat minus 6 K hat. Good, perfect, perfect. R across the top, negative 0.6, negative 0.35, negative 0.6, 18, negative 27, negative 6. Across these values, we're gonna get right over here. Negative 14.1, negative 14.4 plus 22.5. It's going to be I, J, K. So that's r cross f. Now we have to multiply this by the lambda, which we got up here, which is, let's see, 1.2 divided by 1.25, 0.96. 0.96. Do the same thing, 0.35 divided by 1.25. This is going to be negative 0.28, and then the last one's going to be 0. So now when you dot product these, we get negative 13.536 plus 4.032, which equals negative 9.504. And that is the answer.